Absolutely. So what we have done, we have done with the spanning tree protocol, and we have seen the multiple scenarios of the spanning tree protocol in yesterday lecture. We have seen the different ways, different topology, right? And in the different topology, we have seen that how the PST was working, like how the blocking ports and how the root port and DP port was elected. And also we have changed the priority to manipulate the root bridge as well. Right? And also we have covered the states of the spanning tree protocol. So basically we have a five state of the spanning tree protocol. One we call it the disable state, right? If you guys remember that, the first is called the disable state means what? Your spanning tree is not there on the particular interface. It means that between the switch one and switch two, this interface is down. That's the meaning of disable state, right? So if you're gonna up this interface, then immediately what happened? It will go in the blocking state just for the millisecond, right? In the blocking state, what he will do that he's just gonna verify is there any loop or not, right? So once the after the blocking, what happened? It will move to the listening state. In the listening state, basically what we are doing that we are just gonna make a RP and DP election. So for example, this guy will become the DP and this guy will become the RP because he's the root bridge right now and he's the non-root bridge, right? And once the listening state has done, in this state, we are going to spend the 15 second, right? Then it will move to the learning state. In the learning state, what happened? We can learn the MAC address, right? So we can learn the MAC address over there. And then lastly, we have a forwarding state. In the forwarding state, now we can send and receive the data traffic. So we can learn the MAC address, we can send and receive the data traffic as well over there. So basically, if you see the common part, right? The common part of this three things, not three, one, let me do one thing. Yeah, the three one is what you don't have or no data traffic is going on over there. So you are not sending any kind of data traffic in the blocking, listening, and learning. Only the data will be travel in the forwarding state, right? Now, then after that, we have also told you that what is the port rules we have. So these are basically called as spanning tree states, right? And then we have a different port roles, right? If you guys remember that we have a port roles is what? So what port roles, like either it can be the DP, that's a designated port, either it can be the RP, that's called the root port, and either it can be the blocking alternate port, right? Alternate blocking one. So any of the ports can be blocking or any of the port can be RP. So on a one non-root bridge, you will have a only one RP, only one RP. On the root bridge, you will not find the RP port. On a root bridge, you will not find the RP port. On a single non-root bridge, only will have a one RP. But on a non-root bridge, you can have a multiple blocking ports as well. Right? So these things we have covered that. And let me show you, as I mentioned that the PBST protocol is a stand for the per VLAN spanning tree protocol, right? Right? The meaning of this line is what? The meaning of this line is saying that for each VLAN, right? For each VLAN, we have a separate spanning tree, right? Separate spanning tree instance. It means that, let me explain you another ways. For each VLAN, right? We have a separate what? Spanning tree algorithm. Okay. It means that if you have a VLAN number 10, take example, you have a VLAN number 10. For the VLAN number 10, we have a separate spanning tree guy. If you have VLAN number 20, you have a separate spanning tree guy over there. If you have VLAN number 1, you have a separate spanning tree over there. If you have VLAN number 30, you have a separate spanning tree. So whatever the VLANs are present on the single switch. So these all the VLANs are present on the single switch one. So on the single switch one, what happened? You are running with the 4 spanning tree instance. So if you are running in the 4 spanning tree instance, your CPU will be high over there. Always. Your CPU will be high, your memory consumption will be high over there. But the beauty part of this thing is what? The beauty part of this thing is what you can achieve these are the bad parts we can talk about, right? These are the bad parts. We have discussed this thing, if you guys remember, in the first day of lecture, right? So these are the bad parts, but the beauty part is what? The beauty part of this thing is what? You can achieve the layer to load balancing. How? Let me explain you. So take example, right? I have a switch one, right? switch 2, right? And switch 3. Okay, so normally in this case, what happened? Normally in this case, what happened? I have a users over there, right? So take example, user 1 is present on the switch 1 and user 2 is present on the switch 3. So these are users are connected with the switch 2 and switch 3 as well. Right? So we have a switch 1, switch 2, right? And we have a switch 3. This guy's a PC number 1, this guy's a PC number 2, right? I'll mix it with the interface as well. So I'll say the 0/0. This guy's a 0/1, right? This guy's a 0/0. This guy's a, sorry. This guy's a 0/1. Guys, please pay attention to this topic because you will understand the PVST layer to load balancing and the behavior of the PVST protocol. 0/1. And here we have a 0/2 interfaces. Okay. So we have a 0/2 over there, right? So this guy, of course, the switch 1 has a lower MAC address. I can assume that the MAC address of this guy will be A, right? The MAC address of this guy will be B. The MAC address of this guy will be C. So of course, the MAC address A is a lower because A represent what? 10, B represent what? 11, and C represents what? 12 in the hex format, right? So the MAC address is the hex format. So A is 10, B is 11, C is 12. So in this case, what happened, right? In this case, the switch 1 will become the root bridge, right? And this guy will become the non-root bridge. So all this switch 2 and switch 3 will be non-root bridge. So this interface will become the DP port, right? A designated port. This interface will become the DP port. This interface will become the RP port, and this interface will become the RP port. Of course, this interface will be in the DP, and this interface will go in the blocking. Now, the problem, if you see right now, this VR by default is running with the VLAN number 1. By default, VLAN number 1 is present on the switch 1, switch 2, switch 3. So the problem, what happened in this case, try to understand, right? We have a 1 gig link over there. Okay, this is the 1 gig link over there, the 1 gig link over there. So if I'm gonna send the traffic, right? If the user 1 is gonna send the traffic to the user number 2, my all traffic will go by the this way. My all traffic will go by the this way. Doesn't matter which VLANs we have. For example, I'll create the another VLAN number 10 we have, okay, and VLAN number 20 as well. So take example, I'll make some other user. So this guy is a VLAN number 10, this guy is a VLAN number 20 now, right? This is 10, 20, and this is the VLAN number 1. Oh, what happened? And same way, if you see, we have a VLAN number 10, and we have a VLAN number 20 over here, and this guy's a VLAN number 1. So it doesn't matter. Either you're sending the traffic for the VLAN number 1, either you're sending the traffic to the VLAN number 10, or either you're sending the traffic to the VLAN number 20. All my traffic will go via what? Switch 1 and switch 3. So eventually, if you see, I'm not utilizing which path? 1 gig. So it's a totally wastage of what? Bandwidth, or we can say that hardware resources. Totally wastage of bandwidth and hardware resources. Because this is the blocking port. Can you see that? On the blocking port, what we are doing that on the blocking port, we are only gonna receive the BPDU packet. We are only gonna receive the BPDU packet, but we cannot send and receive the any kind of data traffic of it. That's the meaning of blocking, right? We cannot send and receive the any kind of data traffic over here, but we can only receive the BPDU packet. So the problem in a default behavior of the PVST is what? The default behavior, if you see the PVST is what? If you don't modify anything, and if you have a different VLANs for all VLAN, if you see that right now, for all VLAN, VLAN number 1, VLAN number 10, and VLAN number 20, he is the root bridge. He is the root bridge. That's a problem. How the problem comes in the picture, because you cannot utilize the 1 gig link. All my traffic will go via this way. Okay, this is the first issue. Second issue, if you see that, what if you have a look, understand this concept. If the PC1 want to send the traffic to the PC number one, right? The best path, if you see that, the best path will be what? The best path will be this way, right? The best path will be what? This way. But which path I'm utilizing right now? This one. The reason is that because this path is a blocking port over there. So spanning tree protocol also create the suboptimal path. It's also create the suboptimal path, because these are my optimal path, right? This is my optimal path, but I'm not able to send the traffic from here. The reason is that because this is the blocking port we have. And how this blocking port comes in the picture? Because of the spanning tree protocol. Please give me 1 minute. Few mosquito was there in. Okay, so this is the suboptimal path that a spanning tree protocol create, right? So to avoid this problem, right? So to avoid this problem, what you can do that you need to manipulate something. You need to modify the topology, and that's how the I'm gonna achieve the layer to load balancing over there. Or we can say that I do have ability. I can create the different root bridge for the FD VLAN. So this is my physical topology right now. What I can do that, try to understand. For the VLAN number one, I'm going to create the logical topology, RAM, switch one, right? Switch two, and switch three, right? What I can do that? For the VLAN number one, I can make this guy as a root bridge. So if I'm going to make this guy as a root bridge, my path will be like this way. Another logical topology, what I can do that? I will get the switch one, switch two, and switch three. What I can do that? I will make this guy as a root bridge for what? For the VLAN number 10 now. If I'm going to make this guy the root bridge for VLAN number 10, then what happened? Any of the link, right? This link will go in the blocking, right? Now this link will be used. Then you see that what's happening. So for the user now that is present for the VLAN number one, they can send the traffic from this way, right? The user data setting for the VLAN number 10, they can send the traffic via this way. Now the third topology that we have, switch one, switch two, and switch three, we have over here. Now we have a like this, not this way. Yeah, this way. And we have this way. So this guy's a root bridge for what? For the VLAN number 20. So we have a user for the VLAN number 20, right? And over the VLAN number 20 now, 20 and 20, they can send the traffic via this way. So eventually, if you see that, I have a root bridge for the VLAN number 20, the switch 3. I have a switch 2 is a root bridge for VLAN number 10, and switch 1 is a root bridge for the VLAN number 1. So previously, if try to understand, if switch 1 is a root bridge for all the VLAN, then I cannot utilize this particular link. If the switch 1 become the root bridge for all the VLAN, then I cannot utilize this particular link. But if I play with the spanning tree protocol, if I manipulate something in the spanning protocol, then finally I can utilize all the paths. So if the PC1 will send the traffic for the VLAN number 1, it will go via like this way. For VLAN number 10, it will go via like this way. For VLAN number 20, again, it will go via like this way. So I have utilizing all the path I can utilize it if I'm going to manipulate the PBST protocol. So default behavior is what? Default behavior doesn't matter. VLAN number 1, it will look for the lower bridge ID. Who is the lower bridge ID? Switch A. VLAN number 20, look for the lower bridge ID. Switch A. VLAN number 20, look for the lower bridge ID. Switch A. But I can change the priority. So normally what I can do that the default behavior, the switch one will become the VLAN number one. That's a root because of the lower MAC address. I can say that, hey, for the VLAN number 10, your priority is 0. So of course, you will become the root bridge. I will say this guy, hey, for the VLAN number 20, right, your priority is what? 0. So of course, you will become the root bridge. So this is how you can manipulate this thing. So now from one physical topology, you can see that I have a multiple logical topology. I have a logical topology 1, I have a logical topology 2, and I have a logical topology 3. Again, you have to play with the protocol. If you don't play with the protocol, then again, you will become a normal engineers. All good. So let me show you this practical right now. First of all, what I can do that. I'll take the same topology that I did. Switching. Okay. Okay, and not this one, spanning tree. Right, and we have STP. Okay, so have a look. Let me turn on this devices and I'll change the body size because normally in the GNS 3 I'm using the different body size. It's 16 now. I'll make it this guy's a 9. Session default setting, save it, and here we go. Switch 1, switch 2, and switch 3. So let me take a sniff. So we have a switch 1. So this is my physical topology that I have, right? What I can do that, I'll simply write on the MAC address of this guy. I'll say the MAC address of the 000, right? That's the MAC address of 0200, and that's the MAC address of the 0300, right? That's the MAC address of the switch name. The priority, guys, give me a minute. So 0300, right? So what is the priority for this guy? So if you look for the priority, so we have a priority is 32768. That's a default priority. Plus VLAN number 1 will become the 327699. Let me write on like this way: 32768 plus VLAN number. Whatever the VLAN number we have, right? Same thing, we have a switch 2, and same thing we have a switch 3, right? So in this case, right now, what happened? I'm going to create the 3 VLANs. VLAN 1 will be already there, VLAN 10 and 20. So let me go to the switch 1 right now. And all the interface will be trunk, right? Switch 1. Enable host name will be switch 1. Do so spanning tree summary. Let me check which spanning tree protocol is enabled. It's RPVST. Let me change this guy, spanning tree mode VLAN number. Sorry, spanning tree mode. And if you see, we have a PVST over there. We don't have a CST, right? Of course, it's a CSTs are totally obsolete now. So we need to change this spanning tree mode on our every switches right now. Switch 2 as well. Enable host name will be switch 2. And here we go, switch 3. All done. So now what I can do that, I'll just go on switch one right now, and I'll create the VLAN number 10, right? And VLAN number 20. Let me create the trunk as well, interface range in 0/021. Switch port front encapsulation dot one Q. I'll leave it right. No need to mandatory. No need to create it. Let's don't make it confused to everybody. Let's get the VLAN number 10 and 20. That's all. VLAN 1 is already there, right? VLAN 10 and VLAN 20. So what happened in that case? What do you think? PBST protocol. It's called as a per VLAN spanning tree protocol. For every VLAN, you will have a single spanning tree instance, right? For VLAN number 1, you will have a one instance. For VLAN number 2, you will have a one instance. For VLAN number 20, you will have a one instance. It means that you have 3 algorithm will be running over there. You have a 3 STA spanning tree algorithm. So if you go to the switch 1 right now, which is the lower MAC address, and if you have a look right now, so spanning tree, what you can find that, hey, listen, for the VLAN number 1, of course, the switch 1 has a lower MAC address. Guys, please pay attention. Switch 1 is a lower MAC address. 32769 is a priority because for the VLAN number 1, 32768 plus 1 will become the 32769. This guy is a root bridge, right? If you go down, why I'm not in the VLAN, so VLAN brief. That's not fitting that. It has to be 1 minute. Well, let me manually define it. So what I can do that? Switch 1 is a oh, I really need to clear that short man. Interface just as one. Switch port trunk encapsulation dot one two. Switch port mode trunk. Because these VLANs are not associated with any interface man. So let's get the trunk so that it will be associated with any one of the interface. Encapsulation dot one switch port mode trunk. That's fine. Anything, either you can manually configure the trunk or not. That's fine. So DTP is also enabled right now, but I'm still doing the manual configuration. Now that's fine, right? So switch 1, which is the root bridge for the VLAN number 1, and you can see the priority. Now the switch VLAN number 10. I'm still on the switch 1, guys. Please pay attention. I'm still on the switch 1 right now. And for the VLAN number 10 also, what we have, I'm the root bridge. What's the priority right now? 327778. 32768 is a default priority. I'm going to add the VLAN number 10. Now it will become the 32778. Same way, if you go to the VLAN number 20 now, what you will find that for the VLAN number 20, I'm a root bridge. Plus 20, it will become the 32788. So priorities keep changing at the VLAN number 1. So whatever the priority you have, that's a default one, it will add the VLAN number 1 over there. But right now, if you have to look over there, switch 1 is a root bridge for what? Is for the VLAN number 1, 10, and 20. It means that this port is still blocking. Can you see that? For the VLAN number 1, DP. For the VLAN number 10 as well, it's DP. And for the VLAN number 20 as well, still DP. And if you go to the switch 3 right now, right, so spanning tree, what you will find that for the VLAN number 1, I'm on the switch 3 right now, right? If you see for the VLAN number 1, still in the blocking 0/0. If you go to the down for the VLAN number 10, VLAN number 10 switch 3 saying that, hey, for the VLAN number 10, who is the root bridge? 100. So according to the switch 3 for the VLAN number 10, he is the root bridge. That's fine. Again, this port is blocking for the VLAN number 10 as well. For the VLAN number 20, switch 3 saying, hey, for the VLAN number 20 as well, he is the root bridge. the 0, 100, that's a switch 1. And according to me, for the VLAN number 20 as well, what happened? So right now, from this physical topology, I'm only creating the one logical topology. I'm only able to create the one logical topology, which is this one. Which is this one. So this port is blocking. But what you can do that, I'll just go on the switch 2 right now. And what I can tell this guy, listen, hey switch 2, you will be the root bridge for what? Spanning tree, VLAN number 10, priority will be 0. So you can change the priority in the increment of 4096. Why the 4096? Because of the 12-bit VLAN number. So I cannot put the 1 over there. You have to go with the this range. Any of the range you can pick it. So lower is a more preferred, right? So default is a 32768. I can go with the this value as well as. That's not a big deal. But I'm just gonna make sure that it should be 0, right? VLAN number 10 priority will be 0. So now what? Previously, the switch 1 was a root bridge for the VLAN number 10. Now it's no more. Now he will be the root bridge for the VLAN number 10. So what will be the logical topology now for this guy? Switch 1, switch 2, switch 3, right? Like this way, because he is the root bridge. In this case, for the VLAN number 1, he is the root bridge. For the VLAN number 10, he is the root bridge. Now, same thing, I just go on a switch 3 right now. On a switch 3, I can say that, hey, listen, VLAN number 20, priority will be what? It's 0. So now I will get the new logical topology that will be he is the root bridge for the what? VLAN number 30. So now this link. So now if you see that switch 3, for the same command, so spanning tree, right? You can see that for the VLAN number 1, according to the switch 3, guys, I'm present on the switch 3 right now. For the VLAN number 1, he is the root bridge. That's the switch 1. And according to me, this interface is a blocking. So for the VLAN number 1, I cannot send the traffic from this particular link. I cannot send the traffic from this particular link for the VLAN number 1. But if you look for the VLAN number 10 now, for the 10 as well, what happened? He is the root bridge. So according to the switch 3, for the VLAN number 1, switch 1 was the root bridge. For the VLAN number 10, he is the root bridge. See the MAC address 0200. And now this interface H0/1 is a blocking. So now this is also blocking for the VLAN. This is for the VLAN number 1. This is for the VLAN number 10. But if you see for the 20 now, according to 20, both the ports, because I'm the root now. So according to the VLAN number 20, switch 3 is a root bridge. So if the switch 3 is a root bridge, then what happened? Both port will be in the DP port. Same thing if you look for this guy, right? Same thing if you look for the switch 2 as well. If you go to the switch 2, so spanning tree protocol, I can see that for the VLAN number 1, 0, 100 is according to the switch 2 now. He is the root bridge, switch 1. Right? If you look for the switch 2 perspective, sorry, VLAN 10 perspective, for the VLAN number 10, I am the root bridge. See? And if I'm the root bridge, both port will be designated port. And for the VLAN number 20, of course, the switch 3 is a root bridge. So I have alternate blocking. So eventually, if you see that, all the switches has a right blocking. If you go to the switch 1 now, switch 1 also have a blocking now. So spanning tree for the VLAN number 1, I'm the root bridge. I'm on the switch 1 right now. I'm on the switch 1 right now. So according to the switch 1, right? For the VLAN number 1, I'm in the root bridge. If you go down for the VLAN number 10, I'm not a root bridge now. Who is the root bridge? VLAN switch 2 is a root bridge for the VLAN number 10. And my ports roles are changed now. Previously, my port role was DP for the VLAN number 1, but I changed this guy. For the VLAN number 20 now, if you see, switch 1 is saying, hey, for the VLAN number 20, switch 3 is a root bridge. The root ID means root bridge. Root ID means root bridge. And bridge ID means my own information, my switch own information. See, the MAC address is different. So he's talking about the root bridge information. He's talking about the own information. And now, if you see, we have a 0/0 designated port and root port over there. Okay, switch 1 doesn't have any blocking port for any VLAN. So I have a 3 logical topology, and that's a beauty of the PBST protocol. Why only 2 ports are present in the VLAN number 10? Because I just made the trunk interface now. I made the trunk interface. That's why. I haven't added any other users over there. And instance, 2 ports in VLAN 10, where is the VLAN number 1 STP instance? All the ports. Whereas in the VLAN, because by default, all the ports are the part of the VLAN number 1. In a VLAN number 10 and 20, I just made a trunk port, and by default, all the ports are the part of the VLAN number 1. That's why. All good. So let me show you guys the another use case of the PBST protocol. That's called as a load balance. How when we change the root bridge in each switch. It's not a often, right? It's a requirement. It's not often. You have to check the requirement of the company. Then you can change the root bridge. So let's see that. What I can do that, I'll show you the load balancing right now. So I will switch 1. Switch 1. I will switch 2. I will switch, not this one. Switch 3. I will switch 4. Right, and I'll take the few users. So I'll take the PC1, PC2, PC3, and PC4. So I'll make sure that this guy's a same VLAN. So I'll take a color for this one. So this guy is a part of the VLAN number 10. This guy is a part of the VLAN number 10. VLAN number 20 and VLAN number 20. Okay. So let's connect this port right now. How long this interface will take to come up in the forwarding state? 30 seconds, listening and learning. So the first thing what I can do that, let me give the IP address on this guy. So I'll check that 192.168.1.1. This guy should be part of the VLAN number 10. This guy will be part of the same VLAN. This guy should be 1.2. Right? And here we have a 20. I'll make this guy a 2.2. And this guy should be 2.1. All done. So of course, all this my interface will be the trunk interface, right? So this interface will be the trunk interface. This interface will be trunk interface because it will be carry the multiple VLAN traffic. But if you see the default behavior right now is what? If you see that my this interface, right? My this interface went to the blocking state, right? My this interface went to the blocking state. That's a problem. It means that try to understand now if you have this kind of topology, see, depend on the topology, the spanning tree behavior will be changed. So in this topology, what happened? If the VLAN number 10 will send the traffic, it will go by the switch 2, right? It will go by the switch 2 only. If the VLAN number 21 will send the traffic, it will go by the switch 2. So it means that this complete path I cannot utilize in the spanning tree. Now, what do you think? A spanning tree is good for the network? Yeah, it's good for the network because it's prevent the loop, but it's bad for the network too because it's a wastage of resources and it creates the suboptimal path as well. Because I cannot even utilize this hardware as well. Can you imagine that? I cannot utilize any hardware over there. So take example, understood this concept now in this picture. If you have one PC over there, that's part of the VLAN number 10, and this guy has IP address is 192.168.1.3 right now. And if this guy said, hey, I like to ping 192.168.1.1, how the traffic will go? Can you imagine that? The traffic will go like this way. Suboptimal path. So spanning tree creates suboptimal path. But I will change this behavior, right? We do have ability, we can manipulate those things, right? So let me define the first IP and on the every PC, then we can change this behavior. This guy should be 1 or 2. This guy should be 2.1. This guy should be 2.2. That's done. Now what? Two things. This interface 0/1 and this interface 0/2. We need to assign the ports into the particular VLAN. So let's go to the switch 1. And what I can do that host name switch 1 and I say the interface 0/1 switch port access VLAN number 10. So if you don't have a VLAN, it will create the VLAN 10 for you. And interface 0/2 switch port access VLAN number 10. Sorry, 20. So do so VLAN brief right now. You can see that I have both the ports in the different VLAN. Same thing, I just need to go to the switch 4 right now. On a switch port, we just need to create the interface, associate the interface into the particular VLAN. So we can see that we have a 0/3 into the VLAN number 10 and 0/4 into the VLAN number 20 over there. So host name will be switch 4. I said that interface 0/3 VLAN number 10 and 0/4 will be 20. And here we go, done. Now what? Now we need to make a trunk, right? We need to make a trunk interface. How? I just go to the switch 2 right now. I'll make this guy the trunk because my interface is going to carry the multiple VLAN traffic, right? Host name will be switch 2. So I'll simply go on the switch 1, switch port mode trunk, and interface 0/2. I think so encapsulation is not going to work over there. So you simply say that switch port mode trunk. That's all. Same thing on the switch 3 as well. We need to make a trunk. So if you just get the trunk on the switch 2 side, what switch 1 and switch 4 will be negotiated, right? Based on the DTP protocol. So same thing, I'm just going to do that on switch 3 as well. Because eventually we need a trunk, right? Because trunk is the only port that can carry all the VLAN traffic. I have a 2 VLAN traffic right now, 10 and 20. Right? So I need to create a trunk interface, interface 0/1. Now what? If you have a look, right? If you have a look the switch port right now, so spanning tree protocol, what you will find that he is not a root bridge right now. You can see that according to the VLAN number 1, I'm on the switch port right now. According to the VLAN number 1, right? The root bridge is this guy. 6C98. Who is the 6C98? I think so is 2. Let's check it on this guy. Yeah, looks like. Get VLAN number 10 and VLAN number 20. Sys 3 as well. The VLAN 10 and 20 is missing on the Sys 3 as well. 10 and 20. So now if you have a look right now, the Sys 2, what you can find that, so spanning tree, you can see that for the VLAN number 10, here is the root bridge on the Sys 2. For the VLAN number 1, here is the root bridge. So for the VLAN number 1, for the VLAN number 10, and even for the VLAN number 20, he is the king. For the VLAN number 1, for the VLAN number 10, and for the VLAN number 20. For all the VLAN, root bridge is Sys 2. So can you imagine that all my traffic will go by the Sys 2 only? I cannot utilize this link, because of the blocking port. Even I cannot utilize the Sys 3 if they don't have any user sitting behind this guy. If they don't have any user sitting behind the Sys 3, you cannot utilize the Sys 3, the complete wastage of hardware. So now you can do one thing. I'll make this guy, I'll say that, hey, you will be the root bridge for the VLAN number 10 because I have user in the 10 and 20, right? I can say that you will be the root bridge for the VLAN number 10 and you will be the root bridge for the VLAN number 20. Simple. So what happened? If I'm going to make this guy the root bridge for the VLAN number 20, all the port will be in the DP for the VLAN number 20. So my traffic will go via this way for the VLAN number 20. And for the VLAN number 10, my traffic will go via this way. That's a beauty part of the PVST protocol. You can utilize it. So I just go to the Sys 3 right now. I'll say that, hey, listen. Done. So same thing on the Sys 2. No need to mention that this command on the Sys 2 for the VLAN number 10, right? Because already my MAC address is a lower MAC address, but just for the safer side, I'm doing that. Best practice. Hold on, this port, you can see that it's an amber state right now. It will come in the green. It takes, yeah, now it's come, right? 30 seconds, listening and learning. Now, do you see any blocking port in the topology right now? No, I don't have any blocking port. Everything is fine. So if I'm gonna send my traffic, have a look. Let me ping first of all, and then I can show you that ICMP request packet. I say the ping 1.2. I am able to ping it from here to here. If I'm gonna ping the PC number 2 to the PC number 4, which is the VLAN number 20, 2.2. So from this guy to this guy, the communication is possible, right? And from this guy to this guy, the communication is possible. We have the communication right now. What you can do that? Let me show you the flow. Come on. And if you see, I can put some packet for the VLAN number 10 over here to 10. You can see that my traffic will go via the upper side because he is the switch 2 is the root bridge for the VLAN number 10. So if I'm sending the packet from the VLAN number 10 to 10, my traffic will go by the switch 2. Return traffic. Done. Now, let me delete this guy. Now let's put the packet for the VLAN number 20 as well. In this case, what happened? The packet will go by the bottom side, switch 3, because switch 3 is the root bridge for the VLAN number 20 now. All good? This is called as a layer 2 load balancing. I'm able to utilize both the path right now. My return traffic is also coming. So in our books, they written like, okay, you can achieve the PVST as a load balancing rate, but practical is not given many places, right? So if you want to achieve in the practical way, you can do like this way, the lab. So that's a beauty part of the PVST protocol, guys. In a PVST, normally what happened? In a PVST protocol, normally what happened? You can, right? You can utilize all the path, and depend on the VLANs, you can create the multiple topology. So for example, let me show you this part as well. For example, if you have a VLAN number 10, 20, 30, 40, 50, 60, then what? Just before law, you say that for the VLAN number 1, I can make this switch 1 is a root bridge. For the VLAN number 20, I can make the switch 2 is a root bridge. For the VLAN number 30, I can make this guy a root bridge. But how about if you have multiple VLANs? Not a big deal. I can make this guy for the VLAN number 10 and 20, you will be the root bridge. For the VLAN number 30 and 40, you will be the root bridge. And for the VLAN number 50 and 60, you will be the root bridge. That's fine. It's possible. You just need to apply the logics over there. Guys, questions. I'm done with the PVST now. The theory part, although mostly a few parts are there that I'm going to discuss now. Any questions anyone has in the load balancing chapter?
Hello,
Yes.
sir. My question is actually why we need a load balancing layer 2 load balancing in STP, sir?
Why do we need layer 2 load balancing? If you're not going to use the layer 2 load balancing, then what happened? This put in the blocking state, right?
Okay,
It's not gonna this put in the blocking state. You cannot utilize the complete hardware. So wastage of money, wastage of resources, and those things. Do we see the
sir.
bandwidth? Yeah, we are saving the bandwidth, man. You can see that if the ports are not in the blocking state, we can save the bandwidth.
Sir, another question is, sir. Suppose, sir, in a real environment, some loop is created, sir, by the help of STP. So, how can we know
By
a
the help
loop
of
is?
STP, matlab, अबे STP is used to prevent the loop. How the loop will be created with the help of STP?
No, no. My question is, sir. Suppose loop is created in a network, sir. So, how can we know that?
If the same MAC address is learning on the multiple ports, then the
Okay,
loop is there.
okay, okay, sir. Thank you, sir.
That's the only way that you can detect it. If the same
Okay,
MAC
okay, okay.
address is learning on the multiple ports, right? That's remember the day one class of the spanning tree protocol. That
Yes,
the
sir.
same MAC address is going to learn on the multiple ports, then the loop will be there.
Okay, sir. Thanks. Thank you, sir.
Any other question, guys? No. Oh, yeah, I have a few question, but how it is still preventing loop even though. So in Nissan Nissan, right? So how it's preventing just for the VLAN number 10, for the VLAN number 10, where is the blocking port? Here is the blocking port for the VLAN number 10. So for the VLAN number 10, here we are preventing the loop. And for the VLAN number 20, who is the blocking port? If you see for the VLAN number 20, I think so the switch 2 will be the blocking. Yeah. So for the VLAN number 20, right, this port is a blocking one, 0/1. This for the VLAN number 20 is a blocking port. This for the VLAN number 10 is a blocking port. So here we prevent the loop. So I cannot send the VLAN 10 traffic from this side. Cannot. Until or unless this link is not down or this box is not down. I cannot send it. So that's how we are preventing the loop in the VLAN 10 and 20. Could we make the VLAN 20 to use less time? I didn't understand your question, Faraz. Could we make the VLAN 20 to use less time? What do you mean by less time? I literally haven't understand the meaning of less time. So you need to elaborate this one. To use it either to use the traffic. No, you cannot do that. Yeah, of course, in like we have some technology. So you, with the help of you can do that, but literally not. In the right now scenario, you cannot do that. Like if you're not implement the quality of service QoS in the layer 2 network, then some traffic you can say, okay, some traffic will go with the higher priority and some traffic will go with the low priority. You can do that, but not now in the default behavior. All good, guys? Anyone else? No, great. That's done for the today, man. I'm a little tired today. Okay. Lots of work today. So that's done for the today. So tomorrow we'll start with the topic is a TC and BPD. That's an amazing topic. Okay. So tomorrow we are done with the PVST protocol. Okay. And day after tomorrow we'll go with the RSTP and MSTP protocol. So before the Friday, we are going to finish this topic. And from the 12th, as I mentioned that, we are going to done with the routing part. We are going to jump to the routing.
Okay.
Hello, sir.
Yeah, go ahead.
Tomorrow will be whose topics?
TCN, topology change notification.
Okay.
Uplink
TCN,
fast,
okay.
uplink fast, back. So tomorrow we'll see that. So normally 30 seconds is taking the time, right? To listening and learning state. We do have ability, right, in the PBST protocol to avoid this thing. So we'll
Okay, sir.
see that how we can improve the convergence time in the spanning tree protocol.
Okay, sir. Okay.
Okay, great.
Okay. Sir, I have a question. I'll send you the message on WhatsApp.
Oh, yeah, right. Yeah.
If you please kindly open that technology
Yeah,
on WhatsApp.
no, that's fine. I have phone is my handy right now. So your question was like this. Let me
If you just open that panel, basically, maybe that might help.
just draw it, that's fine. Switch one we have. We have a switch two,
Yeah, that's right. Yeah.
switch three we have, switch four we have, switch three we have.
Yeah.
So 0 to 100 is a MAC address, 0 to 100 is a MAC address, 0 400 is a MAC address, 0 300
300.
is right.
And
So
double link in the between.
this was the root bridge was there, and there are two links over here right now. Yeah, what was your question?
Okay, the question was, okay, if we find out if we go through the whole steps, okay.
Okay, so
So-
I'll make sure that this is the root bridge, DP port, this is the DP port, this is the cost is 100 right now on IP-Link, right?
That's right, yeah. Yes, so the switch one is it's a root bridge,
One is
okay.
a root bridge, so here will be the DP and DP, right? Everywhere.
Yes.
According to the switch to this interface will become the
It's a root port, correct, yeah.
this also the root port, right?
That's right. This is also root port.
This is also root port, and now on the switch port, who will become the root port? Because the cost will be
Yeah.
tied from this side and the cost will be tied from this side, right? So we can ignore
Yes.
this.
Yeah, I mean,
Absolutely.
And guys,
Just calendar was funny, but
give me 1
please,
minute.
I had a meeting, I got. to
Okay.
go to get-
Now, if you see this guy, if understand this concept right now,
Two people
if
got
the
two meetings.
BPD will be generated from the switch one, right?
Calendars.
It's come to the switch port, and BPD generated from the switch one to this interface as well, right? What is the cost is happening on the switch port? 100 and 100. The cost is tied now.
You can't, just 1 second, let me open the notes, 1 second. Just 1 second.
Well, if not, well, there's an office, so we'll get it booked in, we need a higher van. Simple. Yeah, did they say they wouldn't book it in there?
Yeah, because it's to do with the accident and repairs and stuff.
Okay, so basically,
But it was okay before it went in.
See, understand, when the switch one is gonna send the BPD packet to the switch 4, right? On the receiving end, we are gonna add the cost 0 plus 100, right?
It's believed,
At the
isn't it?
same time, switch one also gonna send the BPD packet from this interface as well as, right? We have two different interface. We will receive the packet on this particular interface 0 plus 100. The cost is tied, right?
But
yeah, the cost is tight, cost is fine, yeah.
Okay, cost is
yeah.
tight. Now-
We had a drive, right? What happened? You're going down the
The
road.
cost
Uh,
is tied,
It's all over the
then
place,
what
you
happened?
can
What
steal
we have to look
What
up.
happened then?
Not like you want from
Just 1 moment, okay.
If the
Oh,
cost is tied, right? Then
The next step is the
lower.
lower
Center
bridge
bridge
ID. Yeah, this is a question, yes.
Okay. So you tell me one thing. So take example, I'll just put the port number as well. 0/0, 0/1, and 0/1 and 0/0, the port number over here. So you tell me if this guy is gonna send the BPD packet, right? Switch one,
Mhm.
right? And switch one also gonna send the BPD packet from this interface, right? Cost we have done, it's tie, right? So we look for the lower center bridge ID. You tell me one
Yes.
thing. When the switch one is gonna send the what? BPD packet, what will be the bridge ID? Take example, the MAC address 000, 000 will be MAC address. And what is the priority? 32769, right?
No,
32768 is the priority plus VLAN number 1, right? Same way also over here.
Yes, the priority is same, I understand that, priority is same.
So
I was,
now it will also tie now.
no, the MAC address on the switch 4 is 0400 and the switch 1 is 0100, right?
Why are you looking for the, we are looking for the lower sender bridge ID. Who is sending the bridge ID? We are receiving.
Switch
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 one is
one.
sending, right? So you have to look for the sender one, not for the receiving one.
Okay,
Understood? You don't look for the receiving part. Why are you looking for the receiving part right now? I have mentioned lower sender bridge ID.
okay, if it is that the case, that's fine. So that means then
So
we
it also become tie now, right? Because we are getting the same
how-
MAC address from both the side, right? From both the link.
no, how come it's the same MAC address? That
How
was the
come
question.
it's the same? Switch port is receiving the MAC address on this particular interface. What's your MAC address? Same bridge ID, right?
And it's sending the same MAC address, is what you're saying.
Also, we are receiving the switch port on this particular same bridge ID, right?
Yeah,
It's
bridge
tied.
ID is fine.
Bridge ID is tied now.
The bridge ID is tied, that's fine. But I'm talking about the MAC address.
Bridge ID is a combination of what?
Is a priority plus MAC address.
So why you're talking only over the MAC address only? Don't talk about the MAC address. I mentioned the bridge ID we have to look. Did I mention over the MAC address over there? No, I mentioned the bridge ID.
Okay, so when the priority is same, that means we were done with just a bridge ID. I see.
Right.
It doesn't have to, it's just if one of them is match, which is like a tie, that's it, we just go to the next
Next step. So now it will also tie now, right? Lower center bridge ID also tie. Then what is the next step? Lower
The
center
next step,
port ID.
lower some port ID. Okay,
Who
so
has the lower
lower,
center port ID? So in this
lower
BPD packet, apart from the bridge ID, we are also sending the port ID information 0/1 and 0/0. Which one is the lower one?
so sorry, which one is that? 0/.
So when the switch one is going to send the BPD packet from this particular interface, they will put this interface number in the BPD packet. When the switch one also going to send the BPD packet from this interface, they will also put the interface number in this BPD packet, right?
Obviously, we're looking at the receiving one. So one is 0/010. The other one is what? I cannot
0/0.
see that. No, I'm talking about the receiving from the switch one. I'm talking about the switch interface, switch one interface, not the switch four
See,
interface.
switch one interface, if you see, when I'm gonna send the I'm mentioning lower sender port ID, right? Lower sender port ID.
Yeah,
So when the
yeah,
switch
that's
one is
fine.
sending the BPDU, he put
Mhm.
this port ID in the BPDU packet, right?
Okay, what is this one? It's a 010, right?
01, right?
It's a 01. It's not a zero. It's just a 01.
01
Okay.
it's there. It's 01.
Okay, because the dot is there as well. Okay, I see.
And now also I'll put the 0/0 in this BPDU packet, right?
0/0. Okay, so that means a
One is the
0
lower
slash
one.
0.
0/0
0
is the
slash
lower
0.
one. So
Yeah.
this guy will go in the RP and this guy will go in the blocking, also blocking, also blocking.
That's fine. No problem. That's absolutely fine. I was just confused about the method. That's fine. It's one of the match. That's we go to the next step. Right. Fine.
You know, I'll tell you one thing. Okay.
Yeah.
So you're gonna confuse the Nazi right now, or gonna confuse
No,
me?
no, no. I'm confused a little bit.
Okay.
You see the switch
I'm not
port,
confused now. I'm okay now.
the switch port on switch 1 is 0/0, right?
Right.
And it's also on switch 4 0/0. Is that tight or not?
It's not, it's fine. We can put the same port number on because this 0/0 on the switch one and this 0/0 on the switch port. But we have to look for the lower sender port ID. Who is sending the BPDU? Switch one is sending the BPDU because he is the root bridge.
Mhm.
Root bridge
Okay.
always send the BPDU packet.
And for example, if the switch port on the switch 1 was 0/, let's say 0/2,
On the
and
switch
on
two,
on the switch 1,
on the
0/,
switch one, 0/2. Okay.
and on the switch 4 0/1, which one would
So on the switch one 0/2 this side and 0/1 is perfect, right? On the switch one is correct.
yeah.
Okay, and now the switch port should be this interface should be 0/1, right? You are making that
No, the other one.
other one 0/. We cannot have a same 0/1, 0/1. We cannot have it.
Oh, you cannot have it.
Yeah,
Oh, okay.
how can you have the same port number on the same switch? You cannot have.
Oh, okay. Yeah.
And
Yeah,
this
got it.
We just need to ignore the switch 4 interface. If they are not to be
yeah.
considered. We
Now
just
in
need
this
to.
now in this scenario, what happened? Try to understand. Now in this scenario, just Boozer has changed this guy to 0/2 now, right? So 0/2 and 0/1. Which one is the lower one?
0/1, sir.
0/1 is the lower one, right? So in that case, what happened? He
Yeah.
will become the RP and he will go in the blocking.
Yeah, that's it. Simple. It's a simple standard formula.
Yeah, it's a simple
Whatever is
standard. For root select
yes.
port, so we always look for the standard
Yeah.
deals, right? Yeah, exactly, right?
Yeah. Lower port
Always
RD
look
will
for
be there.
the root center one. See,
Yeah.
I have, if you see that, I have mentioned this thing in the paint file, in the video. Always lower center port ID, lower cost, lower center bridge ID, lower center port ID. So always center bridge ID, center port ID.
No problem. That's fine. So that's okay. Thank you so much for please do me a favor. Can you just upload the video we just done it today into the
Yeah,
drive?
I'm just
So
gonna upload it right now, just in the 10 minutes max.
so I will just run because I missed most of the part that I was traveling. So I will
Yeah,
just
no worries.
I'll go through now.
Sure.
So I will
And do this lab.
I will call you later on today after
Sure,
1 hour.
Sure, sure.
Thank you so much. Cheers.
Thanks. Bye-bye.
Thank you, sir.
Thank
Thank
you.
you.
Thanks, Vinny.
Good night.
Good night. Good night.
Good